Back in Lesson 4, we learned that the Android runtime will kill apps with no visible activities in order to free resources needed by the foreground app. But what if your app has tasks that need to continue when the activity isn't visible? Things like downloading files, uploading photos, or playing music. Well, there's an application component for that: services. We've already introduced activities, content providers, broadcast receivers, and intents. Services are the final piece to the Android app component puzzle. You start services much like you do activities, by passing in an intent to a start service call. And you can stop services the same way, by calling stop service and passing in the name of the service you want to stop. Unlike activities, services have no user interface, and they run at a higher priority than background activities. This means that an app with a running service is less likely to be killed by the runtime in order to free resources for the foreground activities. In fact, by default, the system will attempt to restart services that are terminated before they're stopped from within the app. This is reflected in their simplified lifecycle. Compared to activities, services are designed to execute longer-running tasks that shouldn't be interrupted. Typically, you'll only need to override the onStart command handler, which is where you begin the background task you wish to execute. But notice that there are no handlers for monitoring changes in state to reflect the app moving to the background. This is because the running service itself sends a signal to the framework that the containing app should be considered higher priority than other apps in the background that don't have running services. In some cases, your service may be performing a task that, while not having a UI, can't be interrupted without interfering with the user experience, for example, playing music or helping with in-car navigation. In these cases, you can indicate that your service should be considered to be running in the foreground by calling start foreground. You'll notice that this call takes in a notification. This will be displayed and can't be dismissed until the service is stopped or you call stop foreground. You'll learn more about notifications a little later with Dan. But for now, note that a foreground service runs at the same priority as a foreground activity, making it nearly impossible for the runtime to kill in order to free resources. Now you may be thinking to yourself, I could save a lot of trouble dealing with life cycles just by creating long-running or even foreground services. Well, I grew up along the coast in Australia, so I learned young that swimming against the current is exhausting and ultimately futile. In this case, that means making it more difficult for the system to manage resources, ultimately leading to a worse user experience. Swim with the current. Use foreground services only when and for as long as absolutely necessary, and stop all services as quickly as possible. It's also important to note that, like activities and receivers, services run on the main thread, so you'll need to use a background thread or async task to execute the long-running tasks you wish to do within your service. To make life easier, you can use the intent service class, which implements the most common best practice pattern for using intents which are executed within a service. It creates a queue of incoming intents passed in when start service is called. These are then processed sequentially on a background thread within the onHandle intent handler within your intent service implementation. When the queue is empty, the service self-terminates until a new intent is received and the process begins again. Services are a powerful tool and it's important to understand how you can use them. But in practice, there's often a framework alternative to rolling your own service implementation, whether that be an intent service for executing background tasks or the sync adapter, which you'll learn about later in this lesson, perfect for performing background data synchronization.